Okay, we're live. So, hello everyone, and welcome to another Tinybird live stream. Today we are going to be talking about BigQuery and the new Tinybird connector for BigQuery. So, I'm Al, and joined by my colleague David,
Hey,
and
everyone.
we are going to kick off with a little TLDR for those of you who can't stick around for the whole session. So, we'll give a quick demo of the highlights of what you can do with the new connector. We'll talk a little bit about how it works behind the scenes so you understand what it is. And then if you can't join us for the rest, you can drop and we'll carry on with a full demo of building some real-time applications with the connector and Tinybird. So let's jump into it. Let me remember to share my screen, otherwise I'll be talking over nothing. Cool. So in BigQuery, I have a table called products. It looks roughly like this. So I've got, everything you'd expect from a dimensional table, product table. It's got ID, name, family, brand, size, price, standard stuff. The data looks something like this. We got some strings, we got some ints, we got some floats. And if we come across into Tinybird, we can go to data sources, add a new data source, and the new one is this over here, the BigQuery connector. So we can click on BigQuery, and it will prompt us to configure the connection to give Tinybird access to the data in BigQuery. So you can hit this little copy button, and that will copy this principal name. And we can follow this link to the GCP IAM console. And once that loads, we can go up here to grant access. We can paste that principal into the box there. And then when we select the role, we can pick the BigQuery data viewer role. Hit save. That'll go away and save. And we can come back to Tinybird. Now, a quick note, we have applied the BigQuery data viewer role there, which is a relatively broad role that gives read access to your data in BigQuery. If you want to, you can go and configure much more fine-grained permissions on your data. So you can configure a custom role, give it permissions over specific projects, datasets, tables, and use that role if you don't want to give very broad permissions. We do have a note at the bottom of the docs page for the BigQuery connector that can take you through doing that stuff. So once you've done that, bear in mind that GCP can take a moment to sync those permissions. So you can come back into Tinybird, hit next, and good. It's synced and it will go through. And we can now pick, so Tinybird demo is my project. And then we can pick the dataset, which is this one. And then we can pick the table, which is products. So if I hit next, so then I can pick the schedule. For this one, I'll do it as a day. So every day, this is going to replace my data from BigQuery. You can schedule up to every 5 minutes. So you can pick the schedule that works best for you. For this case, we'll say, hey, this data doesn't really change that frequently, so we'll do it once a day. And we'll hit next. And that's going to go away and it's going to read a little sample of the data so that we can see a little preview of it. And it's going to pick up all of the names of the columns as well as their types, and it'll do some type conversion to work out, what BigQuery type should be, what type the column should be in Tinybird based on its BigQuery type. So it's picked up, that these are some strings and we've got a float 64 and an int 64. That looks fine. If you want to change them, you can hit the little dots and you can set them to nullable if there's going to be null values or anything like that. You can also apply TTL if you want to, and we can change the name of the table in Tinybird up here. So I can get rid of that and I'll call it prod. And then we can hit create data source. So that's going to spin up some things in the back. And I want to quickly explain what is actually happening when we do that. So I'm not going to spend too long in these slides for this TLDR. I just want to show you this diagram. So what is actually happening behind the scenes is if you were thinking how you would build this yourself, traditionally, you'd have some sort of ETL tool, batch process that would go away and pick up all of the data. You might have something like Airbyte, 5tran, something like that. And that would go away, read your data, package it up, and send it somewhere. Now, you'd probably have a scheduling tool, maybe Airflow, that could, you'd configure your schedules and it would trigger those processes to happen. What we're doing is effectively all of that for you. So you define your schedule in Tinybird, we manage that schedule, we run the scheduler. The process to actually extract the data from BigQuery, convert it into something that Tinybird can use, and then send it to Tinybird is all happening our side. So we are managing all of that, the infrastructure and the services for you. So you don't need any external tools to use it. Now, the other nice thing is that as part of this, we've developed what we call the CDK, which is the Connector Development Kit. And this is effectively a library we use to develop these connectors. And it handles all of the repeatable boilerplate stuff. So it's BigQuery today, but using this connector, we can turn around and rapidly develop new connectors for different systems. That might be in other warehouses, other databases, other event systems, whatever they are. And you'll get the same experience out of the box. So whatever it is, if you've used a BigQuery connector and we have one for, Apache Pulsar or something that comes out, you'll get a relatively similar experience. The last thing to note is that although we're doing all of this in the UI, it is all in the CLI as well. So creating those connections, doing the schedules and all of that stuff, you can do it in the CLI, you can do it programmatically, you can stick it in Git, you can put it into your CI/CD processes. If that works for you, it's up to you.
And there's one more thing to add. You created that new table to refresh on a daily basis, but you can also add a cron expression to have much more fine control over how often you want that table to be syncing from BigQuery into Tinybird.
Yeah. The other thing as well is it gets better. You don't just have to sync the whole table. You can actually run a SQL query that can be evaluated. So you don't have to just say, hey, load the entire table. You can say, just load the result of this particular SQL query that runs against your BigQuery table. So anyway, back in Tinybird, once you've created the connection, note that it does not run the sync immediately after creating the connection. So because we've created a schedule, it's going to wait until the next iteration of that schedule before it runs the first sync. So obviously, if you want to trigger it to go and do a sync immediately, which we do here, you can go and hit this sync now button, and that'll go away and run the sync. So it shouldn't take too long before we start seeing some rows appearing. I'll just keep giving it a refresh and do a little bit of a dance while we wait for the first few rows to appear.
Yeah, and just another comment here. So as you showed back in BigQuery, this products table is I think it's about 100,000 rows, which in Tinybird speak is a relatively small table. We did want to show it with more than just a couple of different products though. We have tested this BigQuery connector up to about 50 million or even 100 million rows. So this is not only meant for your small dimensional tables, but this really can work at a much larger scale.
Yeah. So the sync is finished, and that's taken all 100,000 rows. And we get a little chart at the top here, which just shows us the history of our runs. So obviously we've only got one at the moment, but you can imagine that once it's done it a couple of times, this shows you the history and the status of them. So if one fails for whatever reason, then you'll get a little red bar, and the successful ones are green. So once we've synced our first table, we can create a new pipe, and the pipes are just a way to start writing your SQL. It's SQL. Anything you can imagine you would want to do in SQL, you can do it here. I'm not going to do anything particularly fancy right now. This is the TLDR. So I'm going to do a quick count. and run that over. And obviously I've got 100,000 rows, so it comes out 100,000. And I can call this my product count API. Maybe you want to know how many products you've got in total, I don't know. But imagine you were doing something slightly more fancy here. And then to create an API out of this, I can hit create API endpoint, hit that button, and I get my API. So this is a standard HTTP API, copy that, paste it in, and I get my count. So very quickly, you can sync in your BigQuery data to Tinybird, write some SQL, expose a HTTP endpoint, and get a very fast, scalable HTTP API out of your BigQuery data. So that's the TLDR.
All done, right?
Now we're going to get into the slightly more interesting bits. So for those of you who are sticking around with us, we're going to go back a little bit and talk about where this fits, why it might be relevant to you, and then we'll kick into a slightly bigger demo where David's going to walk through actually building some more interesting APIs and actually joining the BigQuery data with an event stream to do some cool stuff. So some of these services should hopefully be familiar to people if you're building with BigQuery. If you are building applications of any kind, if you're a retailer and you've got points of sale, or you're an e-com and you're bringing in transactions from the website, whatever it is, you're probably sending a lot of that stuff to APIs. It might be running into message buses, probably going into something like PubSub, and then you might be using Dataflow to wrap that up, send it into BigQuery. These days you're probably running dbt over the top to do some transformations, and this is powering things like batch exports, reporting, BI, the general stuff. I mean, this is kind of the, this is what everybody wanted to do, right? For the past sort of 10 years, it was, hey, how do I do this stuff at a larger scale? And this is what people have built. And it works great, right? And generally you can get this down to sort of minutes maybe, but quite often it's hours of freshness. So the data in BigQuery can, usually be within minutes or hours behind real life. Where you can start running into a few issues is when new requirements come up, right? We've built these systems for a purpose. They work great for that purpose. It can get a bit tricky when somebody comes along with a new requirement. We want to do new things. And quite often that is, we want to start doing applications, or we want to start doing automations. We want to do more intensive things, more interactive things. So, for example, you might want to be building better segmentation for your marketing teams. So it's quite often we hear about a marketing team says, hey, look, people can come onto our site, they can do a thing or two. We know a little bit about them. Maybe they buy something today, and then they come back to the website once a month and they don't buy anything else. And we want to be able to, target these people and with something intelligent to say, hey, come back to the site and this is really relevant to you, or we've got an offer on, come and buy this. And people want to be able to do that much quicker. And like the closer to that decision point you can get, the more effective it can be, right? While somebody is on the website shopping, right, and they look like they might be about to leave or they're not going through to the basket, if you can get them right at that point and try to encourage them, then it can be much more effective than trying to come back to them a week later once they've already gone somewhere else, found a better deal, decided they don't want it. You might be doing something similar for purchasing teams, for example. So quite often purchasing teams are trying to work out, hey, what is performing better in this area? What is selling right now? If you're on, if Black Friday's on, then stuff just happens at a velocity that is very hard to keep up with, right? There is a lot of deals on, a lot of people shopping, stuff is going out of stock very quickly. You want to be able to react very quickly and say, I need more stock of this item over here. Otherwise, we're going to lose out on sales. And all sorts of real-time applications. I mean, the amount of real-time applications that we deal with without even thinking they're real-time analytics applications is pretty crazy. If you think about like Uber Eats and all this kind of stuff, those are real-time analytics applications, right? Whether you recognize that or not when you're interacting with them, I'm certainly not thinking about that when I'm using them, but they are. And doing that stuff over the warehouse can be pretty challenging. And so quite often you can end up with something that looks like this, where you've got your same flow of your warehouse, but building an application to talk to the warehouse, with a lot of concurrent queries with very low latency is pretty difficult. So we end up putting extra bits on top. And that's quite often something like Bigtable or a low latency store, where on a schedule, we transform and then extract the data from the warehouse and stick it into just a serving layer like Bigtable. And then we have to go away and build some sort of custom API, with an ORM and picking some sort of API library that you have to, build and manage the infrastructure to scale it and secure it and all that stuff for your API to serve your application. Quite a lot of moving pieces, quite a lot of complexity to do it. And at the end of the day, when you're doing it off your warehouse, you can still have issues with freshness. None of this really improves the process of getting data into the warehouse, which can still mean that your data is hours or minutes old. And if you think about, you're building Uber Eats and you order some food and the data is only like 3 hours fresh, so it can only tell you where your food was 3 hours ago. Not particularly useful. So this is where Tinybird comes in, and this is the kind of area that we tried to change, which is you've got real data coming in all the time. You've got event streams. You can send that straight into Tinybird. You can query it just using SQL and then publish those real-time APIs directly out of Tinybird. Now, that's great if all you've got is event streams coming in and you want to be able to do stuff and publish those. But the reality is that most of us have already got a warehouse. We've already got somewhere that is the single source of truth. We've got our customer data, we've got our product data and all of that stuff in there. So on top of wanting to be able to work with event streams very fresh, we actually want to be able to bring in our existing dimensional data to enrich that stuff. So what we've changed, what we've done that is new that we're talking about here today is the BigQuery connector. And what this lets you do is use Tinybird as you would normally, bring in all your event streams and publish real-time APIs off of it, but then bring your data from your existing BigQuery into Tinybird and be able to build APIs off of that, or even join it with your event streams and build APIs off of both of those. So now you can continue to use your BigQuery, your warehouse, for all the stuff that it still makes sense to use it for. So your reporting, your BI, all of that stays with BigQuery, the tools you know and love. And then all of the real-time stuff can be handled by Tinybird, which is purpose-built for that, and enables you to do all of the stuff that you wish you could do. So user-facing analytics, real-time segmentation, real-time personalization, anomaly detection, and everything else you can possibly think of. And so that is hopefully giving you a good idea of what we are looking at and what we are trying to do. And I think I'm pretty much done with the slides there, so we can actually get into the meat and potatoes, as they say.
Let's see this
David
in action.
Can build you something.
Awesome.
So, David, if you want to take over, if you want to add your screen.
Let me share my screen right now. Okay, great. So now that we're through the slides, today we're actually going to be building the backend for this very simple dashboard that's serving e-commerce insights to two different personas. And Al already touched on these. One is the sales team and the other is the marketing team. And so let's imagine that right now we have an e-commerce store and people are actively shopping for clothes on it. And the sales team is interested in things like the trend of sales over time and the top products. We can filter on a specific product family, like just sweatshirts, or maybe, I don't know, just jackets, or we can look at all of the products here. And then the marketing team is interested in the source of the sale. So if I switch over to the marketing tab, here we have this donut chart that's breaking down the number of sales by the source, whether someone's shopping on Instagram, through a search engine, TikTok, and so on. And then, of course, also which stores are actually selling the most. And so you can see here that if I go back to sales, every time I'm refreshing this dashboard, or every time I'm making a new selection in this dropdown, that these numbers are changing very rapidly. So what's actually happening here is that to simulate people actively shopping, we're sending live events to Tinybird's Events API endpoint. And then each interaction on this dashboard is making a new API request. So let me just show that if I open up the developer tools and just refresh this page. You can see here that we have 4 different API requests. And each of these different APIs is powering each of these 4 visuals. And so we're continuously streaming in data. And then when I make any change here, we're always querying that freshest data with those API requests. And of course, this is a really basic example, but like Al already mentioned, fresh data and low latency are incredibly important, across the board, but specifically to in e-commerce examples for retailers because of events like Black Friday. You don't want to be querying old data. You don't want to have really low latency. You need to know what's happening right now. So to actually recreate the back end for this dashboard, we're going to recreate those 4 API endpoints on top of 2 different data sources, the live event stream and the product data from BigQuery. So jumping back to Tinybird, I'm in that same workspace that Al was sharing before. And luckily, he's already done the hard work for the BigQuery data. And he's already imported this product data and set this up to sync on a daily basis. And so like he was showing before, this data source has some data like the product ID, the product name, the family, this fictional brand that we created, and the price. Also, like you showed, we have this pulse chart that's showing the status of these different sync jobs. We can also look at the log, so we can see what's already happened in the past. So I can see when he created it and when it ran that first full replace. So the hard part for BigQuery is already done. Now let's recreate this new events data source. So like I said, we're right now streaming data to that dashboard. And I actually have that running on a sort of our backup workspace, just so we have something to show. But the way that we're actually generating that data is with this data generator that we call Mockingbird. It's this internal tool that we're using to generate some of this dummy data. So right now I'm going to stop generating. And you can see here just a preview of the data that we're sending in each of these events. So we have things like the timestamp, the store ID, the product ID, the number of sales, and the UTM source for the marketing team. So in order to start sending this to my new workspace, I'm going to go up to Tinybird settings. And here I have a couple things to configure. So the first is the name of the data source, which I'll just leave as events for now. And then I just need a new token to start sending to my workspace. So I'm going to flip back to Tinybird and go to auth tokens. And I have already created for me this data source token, which has a certain scope to be able to create new data sources and append to existing ones. So I'm just going to copy this token, go back to the Mockingbird, and paste that in. I'm right now in the EU region. And instead of 567 events per second, why don't we just start sending 1,000 events per second? I'll click save and start generating. And you'll see that this is going to start sending events. And when I go back to Tinybird and go back to the dashboard and refresh here, hopefully I'll see that I have this new events data source. And so immediately, without having to pre-configure anything, Tinybird automatically created that new data source and started receiving data. This is great for speed and for testing. But of course, as you start iterating on your project, it's usually a good idea to predefine your schema so that it's optimized for your use case. But like I said, for speed purposes, this is perfect. All right, so now we have our two data sources and we can start building these endpoints. So the first one I'm going to build, if I just flip back to the dashboard for a moment, I'm going to start with this, the sales persona, and I'm going to start with these two charts right here. And actually, I'm going to start with this sales trend one. So all this is showing me very simply is the number of sales by hour. All right, and let me flip back to Tinybird. And so now I'm going to create this pipe. All right, so let me call this hourly sales. And first thing I need to do is use this to start of hour function so that I can cast my timestamp to the hour. And then simply just sum up the sales as total sales. And then also group by hour and order by hour. One thing that's missing here is the filter on the product family. And if I just open up the preview of my events data source, and if you remember back, in this events data source, we only have the product ID, not the actual product family. And so in order to be able to filter on that, I'll have to do a join with our prods data source from BigQuery. Let me just open up a preview of that to remind myself what fields I have here. So I'll join prods on where product ID from events equals ID from BigQuery. And I can add this condition to filter on the family. And just for now, I'm just going to hard code it just to keep things simple. But we can come back to it and turn it into a parameter later. Okay, great. And so that's working. And let me just auto format this to make it nice and pretty. And now that I have this endpoint, all I have to do is publish the endpoint. And just like that, we now have our first endpoint for that chart. So this is great. And I think we can expect that this endpoint is going to perform well over our thousands or tens of thousands of events that we have right now. But as we scale up to millions or even billions of events, if a Black Friday is approaching, doing this join and this aggregation at query time can really slow down the endpoint. So instead of doing this at query time, we can make use of one of the superpowers of Tinybird, which are materialized views. So I'm going to create a new pipe here. And I'm going to essentially redo that join that I was doing. So again, to start of hour, timestamp.
Just while you type that, David, we had a question. Carry on. We had a question in the chat, which is full sync. So in this case, we are doing a full sync from BigQuery. So all the 100,000 rows that we had from BigQuery, we synced into Tinybird. You can write a piece of custom SQL to modify what you sync, so you don't have to go and sync the full table. But in this case, we did do a full sync.
All right, so I'm again just doing this join. I joined with the products table again, and let me bring in the name, family, the brand. What else do we have here? And the price. And I can now use that price to calculate the revenue. So if I just do sales times price as revenue. And then need to group by all those fields. Auto format this. Okay, great. So I've now joined our live event stream with our product table from BigQuery. And instead of creating an API endpoint, actually, let me first rename this pipe to just mat hourly sales for materialize. And I'll just name this node to MV. So now instead of publishing this as an API endpoint, I'm instead going to create a materialization. And I'm going to rename this to MV hourly sales. I can define here the sorting key. And since I know that we're going to be filtering on family, I'll choose that as the first field. I'll leave everything else as default. I can choose to add a TTL if I want, just like Al showed on the data source, but I'll leave it as is. Click next. And I'm going to populate with all data. So when I click create materialized view, and as our data volume grows, what this materialized view is going to do is reduce by orders of magnitude the size of our data source, which the end result being that our queries built on top of this data source will be much faster. And so as events are now being ingested, they will automatically trigger this materialized view, which will join the product table from BigQuery and sum up the sales by all these different fields. And so by shifting these transformations back to the ingestion time, our endpoints will be much faster. So now that we have this materialized view data source, let's go back to the hourly sales pipe and update this to, instead of reading from our raw tables, we can read from that materialized view. So first thing I'm going to do is in a new node, let's just select star from MV hourly sales. And rather than hard coding the family name like I did before, let's now add in our parameter. So we want to select star where family equals, and I'll use the templating language to define a string parameter. So the name of this parameter, I'm going to call it family param. Give a default value of, let's say, jacket. And then for documentation purposes, I can add a description or if it's required. And I'll just leave that as is for now. And when I run this query, you'll now see that I'm only getting these records where the family is jacket. I'm going to flip back to the dashboard for a second. You'll notice in this dropdown that I have all of those different options for the families, but I also have this all option. So I need to add some logic into my query that says, if I choose all, then I don't want to apply any filter. So back to Tinybird. I'm going to, again, use a templating language to add a conditional statement. So I'm going to say, if family param does not equal all, then I want to run that. Then I want to filter where family equals that value. Otherwise, I don't want to filter on anything. So I'll just add an end here. And in the front end, if I do choose all, this condition is going to be completely ignored. So I'll have this sort of floating random where here. And in order to make sure that doesn't error out, I'm just going to add a sort of dummy condition that will always be true, just in case that happens. And I'll have to add an and here. On that, okay, great. Let me auto format that. All right, so let me just rename this to filter data. And now that we've filtered with the family parameter, now we can aggregate it. So for this first chart, again, super simple. We just want to, we've already passed the timestamp to hour. So let me just grab that column and rename it to hour. And then I simply have to sum up the sales as total sales. And then I can group by hour and order by hour. All right, and so this endpoint is already published, so I can click right here, and instead of having that previous node published, I can republish with this node as my endpoint. And if I go to the View API page, I should see in my available parameters that I have this new family param that I just defined. Okay, great. So that's the first API done. The second one is this top 5 products by revenue. So to make things easy, I'm just going to duplicate this pipe I just created so I can reuse that same filter logic. And I'm going to rename this to top 5 prods. I think I can get rid of this first node here. Okay. So I already have the filter logic, and I want to be able to reuse that. And now I can just update this node here. So first, let me just select star so I see everything that I can use. And let me just flip back to the dashboard to see what I need here. So here we have the actual product name. And then we also have this brand that's concatenated with the product name and the actual revenue amount. So back to the pipe. Let's use the concat function to concatenate name. Why don't we just do dashes and brand, and I'll just call that name. And then here we can sum up the revenue. And I'm going to call this value. Okay. And I need my group by. And I need to order by revenue descending. Oops. Order by value descending. And I need to add the limit so that we only see the top 5. So limit 5. Great. Let me rename this node to endpoint and publish. All right, 2 endpoints down. Flipping back to the dashboard. So here we have the total sales by the UTM source. So I'm going to copy this top 5. I'm going to duplicate this top 5 prods because I think we can reuse this logic. Again, have the same filter logic here. Get rid of all this. Here we just want the UTM source and sum up the number of sales. And we want to call this total sales. Group by UTM source. As you can see, each of those different sources, like I showed before, TikTok, Instagram, and so on. Create API endpoint. All right, 3 down. And actually, let me rename this one. This needs to be called sales by UTM. Okay. And the last one is showing this trend of the sales broken out by these different stores. This is also showing by hour. So I'm going to duplicate my hourly sales pipe. Again, get rid of this old node that was there. So now we just have our filter and then summing it up by hour. What's actually missing here is the store ID. So if I just add in the store ID first. So you can see that this is now showing our total sales broken out by hour and by the store ID. But instead of showing it this way, I sort of want to pivot this data so that I have a different column for the sales in each store. And to do that, I'm going to use, rather than just summing up sales by store ID, I'm going to use the SUMIF function. So here I want to sum up sales if the store ID meets some certain condition. So if store ID equals 1, and then I will call this store 1. And let me just make sure that that's working. Great. So now we just have the sales for store 1. And I will now copy this 5 more times. And go through and just change each of these conditions. Store 2, 3, 4, 5, or 6. And I will change the column names as well. Oops. Okay, great. So now by hour, we have a different field for each of the sales by store. Let me rename this pipe to hourly sales by store. And I'm ready to publish. Okay, so I have all 4 of my endpoints now. The very last step is to create an auth token so that the dashboard can make authorized requests to each of these endpoints. So again, I'm going to use the UI to create this token, but like Al mentioned earlier, you can use the APIs to do this as well. So let me call this dashboard token. And I'm going to add each of those pipes to the scope. So we need hourly sales, top 5 prods, sales by UTM, and hourly sales by store. These are going to have read-only permissions. Save changes. And now if I copy this token and go back to the dashboard, I should be able to totally replace this token, and hopefully it works. So first thing I'm gonna do, if I clear out that token from the old workspace, everything goes blank. And if I paste in this new one, I should see my new charts. And let me go to marketing, make sure that works. Great. So this all seems to be working. Let me just make sure that my parameter is working correctly here. So let's select sweatshirt, and we see that these values are changing. You can select jeans, for example. Great. So that's about it. In, I don't know, 20 minutes or so, we were able to build this real-time dashboard that's working on top of live stream data, live events they're streaming in, and joining that with data from our BigQuery data warehouse. So, Al, I think back to you.
Lovely. Well, you got a round of applause in the chat there,
Thank
which
you.
is more than I got. So you've clearly done a great job. Great. So I mean, that's really all we had to show you today. So we've, in under an hour, we've built a real-time application joining streaming data with a slowly changing table synced from BigQuery with no additional infrastructure required on your part. All we have left really is to talk about where this is going in the future. So at the moment, the sync strategy, that's the word I'm looking for, is replace. So every time you do a sync, it will completely replace all of the data that you've synced last time. Coming very soon will be the append strategy, so that you can say, today sync data between timestamp 1, timestamp 2, and then tomorrow sync data from timestamp 1, timestamp 2, and just append it to the end of it. So that will come very soon. Obviously, now that we've got this the CDK, BigQuery is the first of many, so expect more connectors so that we can go and repeat exactly this with whatever your source of data is. Yeah. So I see that there's a question that's going into Slack rather than in this chat, so we'll tackle that one separately. But unless anyone has any more questions for us right now, then we'll call it a day, and we'll hop into Slack and answer your questions there.
Yeah, great. Yeah, I guess just use this to shamelessly plug our Slack community. So if you haven't joined already, you can join our Slack community for free. There's, it's a very lively community. There's a bunch of questions that people are always asking. So great place to be if you're starting to use Tinybird. And on the note of new connectors that are in the works, definitely let us know if you have any requests, any data warehouses or any other sources that you're using today that you think could benefit from a connector like we just shared with BigQuery.
Awesome. Well, no more questions coming in, but thank you for the feedback, and we'll see you in Slack.
Thanks, everyone.
All right. Cheers, everyone.